Hey scholars, we are in the last section of our chapter 12 unit, and today we're going to talk about tessellations, and we're also going to talk about symmetry. Now, so this isn't really quite with transformations, and I just want a quick review. Remember, there's 4 types of transformations. You have reflections, you have translations, you have rotations, and you have dilations. And remember, 3 out of the 4 are isometries. But on this, we're actually talking about the symmetry, which we talked about a week ago on Friday. And so just remember all the different little details that we have on this. You're going to be fine. Well, the first thing you need to remember, what makes something with symmetry? All right, a figure has a symmetry if there's a transformation of the figure such that the image coincides with the pre-image. So that means if I have it, it becomes exactly the same thing. So it's the same idea. Kind of like, remember when you were a little kid and you would fold a piece of paper in half and then you would cut out the heart and then you'd unfold it and there you would have your perfect heart. Well, that's the idea of symmetry. It's the same on both sides. Now, we have what's called line symmetry or reflectional symmetry. I think I called it reflectional symmetry last week, but I said, remember, it's the same thing. These mean the same thing. You're going to hear me refer to it both ways. It has this type of symmetry if it can be reflected across a line so the image coincides with the pre-image. It means if I reflect it here, it looks exactly the same on both sides. And remember, pre-image is your original, image is your last. The line that it reflects across is just the line of symmetry, so it's not a real big deal here. And that makes sense, just really the idea. And remember, it just is the axis, like I like how they call it the axis that divides it in half. You could flip it over. Also, you're supposed to be able to identify all the different lines of symmetry that you possibly could have. And I'm trying to find a good ruler here. And so I think I'm just going to use a note card that you have. Now, sometimes things have symmetry and sometimes they don't. Now, here on this kind of like starburst type of idea, you can easily see that I can draw a line of symmetry going straight from the top to the bottom vertically. And you can easily see, oh yeah, I can go across horizontally as well. But if you notice, you could go literally through every opposite starburst here, so we can use these to our advantage here. So we get this one as well. There's another one. All right, so now here's my question. Are those all the lines of symmetry? Those are the ones we normally would notice first, but I want to watch right here. How about if I go in between the lower levels here? Or they dip in. I can get another line of symmetry. Notice I can do the same thing going this direction. We have another line of symmetry. We have another one going this way. Another line of symmetry right here. We have the last one here. Sorry it's taking so long. This one has a total of 8 lines of symmetry. Now, here's the number one thing you have to do. If you're ever counting the lines of symmetry, you can't double count them. So you kind of need to put your finger at the top and bottom of the single line and go 1, 2, 3, 4, 5, 6, 7. Oops, I forgot one. And there would be our 8th one. But you don't want to count this one again because you've already counted it to start with at the top. So this one has 8 lines of symmetry. So it does have line symmetry. It has 8 lines of symmetry. Now let's look at the next one right next to it on B. Now, does this one have any symmetry with this? I'm looking at it and I'm thinking, I can't go across, I can't go horizontally, vertically. And so this is a scalene triangle, and the scalene triangle doesn't have any. So does it have symmetry? Line symmetry? No. Now how about like our red cross symbol right here? Well, it definitely does have symmetry, because right away you know, oh, I can totally divide it in half. Now I'm eyeballing half here, so guys, if it's way off, I'm so sorry. And I know I can go basically in half this direction. Go in half. I'm going to go in this direction as well. So you should have a total of, I do believe, 4 lines of symmetry when you're doing this. So 1, 2, 3, 4. So, yeah, 4 lines of symmetry. So that's not too bad. And then we have, it's almost like we have these 2 trapezoids put together. But this one has just 2 lines of symmetry. You're going to have a vertical line of symmetry. Let's see if I can get about halfway here. It's hard when I'm just eyeballing it and not measuring. And then we have our other one coming to our 2 points. Your second line of symmetry. So yes, this one also has 2. So it's not too bad, but we do need to make sure we understand where all those come from. Now let's try another one on the next page, and then we'll talk about another type of symmetry. Now here is a typeset. This is actually a capital letter B. I'm not quite sure which font, but they use the idea. Now, when you initially look at it, you kind of think no, but then when you think closer at it, you realize there's a line of symmetry right across the middle, horizontally, of the B. And that, when I'm looking here at the flag, a lot of people instantly say yes, but I'm actually going to say no. And here's why I'm going to say no, because if you weren't looking at the stars, you instantly could have done a line of symmetry right here. But if you're looking at the stars, notice if I tried to draw this, if I can go through it better, this star doesn't reflect onto itself, and those 2 stars right there do not reflect. So this one's no. There's no line of symmetry on this one. And it's because if you were reflected, remember, like if you'd fold it in half, it doesn't land on each other. So the stars weren't quite in the right spot. So, all right, that's the end for line symmetry, and then I'm going to talk to you about rotational symmetry.